Now, before we move ahead with object-oriented programming in Python, I will take you to a walkthrough of how the code and the way of writing code evolved over years and how it finally has become now. So, the first approach towards the code was actually procedural programming, or this is also known as functional approach that solves the problem of repetition in our code. So now, do you remember the example of a teacher that I gave you when I was teaching you functions and recursion? So in that example, a teacher had to store data of 100 students. So in that case, he actually could not create a variable name, age, and marks for each and every student for 100 number of times. So to do that, functions were actually so to solve the problem of repetitions, functions were actually incorporated. So to solve the problem of repetitions, functions were defined in programming, but functions had their own limitations, and those were they actually could not represent a real world entity. Like suppose I want to describe a person who is blind by birth, that how a cat in real world is. So how will we do it? Because he actually cannot see, or he even might not have even observed how a cat behaves in real world. So to make that person understand, we will actually start describing him like there is a species cat on this planet Earth, and almost all of the species are having four legs. They have a tail, they make their characteristic sound, they have two ears, and in this manner you will proceed by telling each and every detail. So, is this possible by using the functional approach? How would you describe him using the functional approach if the person was none other than your computer? How will you do it? If you actually followed the functional approach, I won't say that it will be entirely impossible and you won't be do it, but I would say instead that it is not a very good method or not a very good approach to solve the problem. So to represent real world entities and to solve the problem of scalability, that is how scalable your program becomes, that is how manageable and how easier to use the program becomes. To solve that problem of functions, we actually defined an entire new approach of programming, and this approach is known as the object oriented approach. Now that it is clear to you why we need the object oriented approach, we will now be beginning with a story to understand how the object oriented approach actually works. Assume that you are a 6 or 7 year old kiddie who, with his friends, decided to play on the seashore. So you took all of your toys and a bucket, a single bucket with you, and went to the shore. There, one of a naughty friend of yours, he thought of a game. He said that let us play a new game. We will make sand castles using the bucket and design them. Then we will describe the qualities of the sand castle and the purpose a sand castle can serve. To make the game more interesting and engaging, he declared that the losers will actually have to help with the homework of the person who will win the game. And you all started to make your castles, but you actually had the same bucket to make castles. So one by one, each of you used the bucket and prepared a basic structure, a basic layout of your castle. And then all of you decided to design your castle, but none of you had the same design on the castle. And then came the chance to speak up about the castle. So you stood up and said that a castle protects us from season, it can help in war, it can provide you shelter and a place to grow safely. And with this speech, you won the contest, and your friends actually had to help you with your homework. And the story ends. Now, let us use this story to understand the concepts of object-oriented programming system. Do you remember the bucket that all of you used one by one to create a basic structure or a basic layout of your castle? So the bucket actually prepared a blueprint, or the bucket already decided how the basic layout of your structure would look like. And this shape giving thing, we call it class in object oriented programming. And the castle that you created using the bucket, that is the shape giver, is the object. And each and every object that is created from the class is actually same in almost every manner. But then you actually designed your castle walls and decorated it. So the object or the castle which was same initially now became different in terms of design. And these designs or the decorations that you make on the castle are nothing but the properties or the attribute of your castle or the object that you have created using the bucket. And finally, when you gave a speech that a castle can do this for me, a castle can do that for me, these functions a castle can serve are nothing but the methods or the verbs or the actions an object can perform. Now, you need to answer me some questions, and those are can a bucket be used to create many castles? So the answer is obviously yes. And can one class create many objects? So the answer is yes again. And do all the castles have the same design? So the answer is no, they don't necessarily need to have the same design. Exactly, those different designs are like attributes of objects. And can all the castles serve the same purpose? So the answer is yes. And those purpose or the actions are nothing but the methods of an object. Now you might be a bit overwhelmed that what are attributes, what are methods, what is this guy saying? So to understand it better, let us actually create a class. And now you know that why do we need object-oriented programming? So we would be good to go with coding. But let me just remind you once again that why do we actually need oops? So the reason is you actually need to explain to a person who has never seen a cat and who indeed never will. So to do this, you will actually write down code, and this code will be the language that the person will understand, as the person is no one but the machine, the computer. And To make him understand, we will write the code, and this code will help the machine to understand how the object is behaving in the real world. So let's begin with telling the computer how a cat would look like in real world. So we will now be defining a cat class. So to define a class, we use the keyword class, and to define the name of the class, we can name it usually like we name variables. But the point that is to be remembered here is that you actually need to capitalize the very first letter of a class. And the reason is because this is a convention that is followed by programmers, and it will be better for you to follow the same. And this is how we actually create a class, a simple class with nothing inside it in Python. So if we actually want some of the properties of this cat, like each and every cat will have four legs. So the number of legs will be four. And if I tell that each and every cat has a tail and the number is one, I will tell the computer in this way. Now, these are the attributes of this cat which have been defined inside this class. Now, if I want to create a copy of this cat, like I told the computer that there exists a species cat on the planet Earth, and that species cat actually has a lot of members inside it. That is, there are hundreds and hundreds of cats. So how will I tell this? I will simply tell it by saying that cat 1 is actually species a species member of this class cat. Now you can relate it simply with the castle example that I just gave you. So this cat class is nothing but the bucket. This cat 1 is the basic structure or the basic layout of how your castle is. That is, you created a castle using this bucket, and these are the very basic properties of a castle. So, like your castle would surely have some height and some width. In the same manner, this cat will actually have some legs and a tail, which we have predefined in this cat class. But can this cat object have some different properties? So the answer is yes. Each and every cat have some different properties, but also have some similar properties. And now the question arises, can this cat always will have these properties only? What if I actually had a cat which had a name and I want to refer that cat with that name? But a cat which is there in my neighborhood is not having the same name. She is having some other name, but she is having these characteristics common. So, can I actually name my cat and make it different from the neighborhood cat? Like you actually deferred your castle design from your friend's design. In the same manner, the answer is yes, you can actually name. And these properties that you can see over here, those belong to the class, are nothing but class attributes. And these class attributes will be common to each and every member of this class. That is, each and every cat that you will tell the computer using this cat class will have these these attributes in common. That is, each and every cat that you will tell the computer will have a tail and will have four legs. Now let us come back to the question of naming a cat. So how do we name a cat? So the answer is we can actually name our cat by simply defining a new property of our cat. That is, I want the computer to know that the name of this cat one, which is my cat, is actually having a name. And the name of this cat is Lily. Now, what actually I have done over here is this cat one is actually having an attribute that is name, and the value of that attribute is Lily. So this is how we define the object attribute, and this is how we define the class attribute. So the difference between the class attribute and the object attribute is that if I created another cat using this same class cat, then this cat too will actually not have any name because I have not given any name to it. I have given name only to this cat, which is cat one, which is my cat. And both of these cats are since created using the same class cat, this will have these attributes, that is legs and tail, common. That is, both of these cats will have four legs and a tail in common. Now let us try to print the characteristics the characteristics now let us try to print the characteristics of the cat one. So I will simply do this by using cat1. Then to access the property legs, I will use a period, and then I will use the legs property. And when I'm going to run this program, you will see that this integer 4 is printed on the terminal. You can see that this integer 4 is printed on the terminal since we have defined the legs to be 4 in number. Now, what if I want to know how many tails a cat do have? So I will run this code again in the terminal, and you will see that it prints 1. It prints 1, and the reason is same. Now, if I try to print the name of this cat 1, will I be able to do this? So the answer is yes. And when I'm going to run this program, you will see that this cat one actually has a name, that is Lily. And if you are thinking that this cat 2 will also have some name, so let me tell you, my dear friend, that you are actually wrong. This cat will not have any name because I have not given it any name. This is some random neighborhood cat, some wild cat that I don't know who it is. So when I'm going to run this program, you will actually see an error saying that this cat object has no attribute name. Now, I hope that you would actually be understanding what this error means. It simply says that the cat object you created, this cat object you created, has actually no name attribute. That is, it is not given any name, and this is the reason why it came up with the error. And this is how the object attributes differ from the class attributes. Now, moving ahead, what if I say that my cat actually is not having a tail? It The tail got broken, and unfortunately, because of a surgery that my cat had to go through, the tail was removed. So, in that case, I will simply assign the value 0 to the attribute tail. Now, what will happen? The class attribute says that each and every cat has tail 1, and this cat 1 is saying that I'm not having a tail. So which one do you think the interpreter will print if I decided to print the tail attribute of the object cat1? So the answer is this this attribute. And by now I hope you would surely be able to answer the why. And the answer is because object attributes are having a higher preference over these class attributes. So this cat1 will actually have no tail. As you can see that this cat1 dot tail property prints 0 on my terminal. And what if I decide to print it for cat2? Will the answer be 0 or will it be 1? So the expected answer should be 1. And the reason is because we have not modified the cat2. That is, cat2 is a normal cat under normal circumstances. It has never been under a surgery and it is a normal living cat. So the answer you can see is 1. Let me just clear the terminal so that you don't confuse yourself with two different outputs. So you can see that the answer is 1. This cat2 is actually having a single tail. So we have seen that how object attributes are preferred over class attributes and how we can define personal qualities of an individual cat outside the class. So now we will actually be moving ahead to the next point, that is the init method. So don't worry what is init method, but let me just tell you something. When this class cat was created on my system, it was actually initialized by my system. So what do I mean by initialized? Without using initialization inside this class cat, each and every cat that you are going to create using this class cat will actually behave in the same manner. That is, this the computer will not be actually able to differentiate between the different cats that you are going to create using this cat class. That is, it will consider my cat and the neighborhood cat to be the same cat. It will not know the difference. And the changes that I'm going to made and the changes that I'm going to make with my cat will actually be implemented on the neighborhood's cat too, which I don't want. So that is why we need the init method inside a class. And methods are nothing but the functions that you define inside a class. So you might be thinking that we actually have not used any initialization in this class cat. So how actually we could differ the cat1 from the cat2? And the answer is quite simple. That is, Python automatically initializes the object if we actually don't define the initialization function inside a class by your own. That is, if I would define the init the init function. Now this init function and the functions like init function are known as constructors in Python. And the reason is quite simple because they actually help in constructing different objects from the same class. And this is the reason why these are known as constructors. And you might be wondering that why do we need this parameter self inside this init constructor? So the reason is quite simple. you remember that I told you that we won't actually be able to differentiate between the different cats that we have on earth, that is my cat and the neighborhood cat, and we actually won't be able to define the properties of each and every cat without knowing that these two cats are different. And in that case, the name of my cat and the neighborhood cat would be Lily. That is, the name would become same. Now, before I tell you the purpose of this self parameter inside the initialization, I would want us to now take a look at the technical definition of the class and the object. So, in technical terms, class is defined as the blueprint of creating an object, and the object is defined as the instance of a class. Now, what do I mean by instance? So, by instance, I mean uh, how this object will look like at a particular point in time. Now, you should be quite confused that what do I mean by a particular point in time. So, let me just make it a bit more clear. So, this cat1 is actually having only two properties for now, and that is tail and legs. Now, what if I actually give it a property eyes equal to 2? Now, this cat will have two eyes. So, when I'm going to print cat1 dot eyes or cat2 dot eyes, you will see 2. Now, at this instance, that is at this point of time, the cat looks like this. So this cat object is an instance of this class cat. And what if I now decide to change and remove one of the properties? Now this cat object will look something like this by default. So by this I mean to say that this object can actually differ at a particular instant of time, and this is what the definition trying to point out, that an object is actually an instance of the class. No worries if you did not understand it. You will actually grasp the concept with time as you practice and write more code. Now let us come back to this initializer. So this type of initializer and some other functions, like this function, that is, this is a predefined method actually. So some of the methods like init and some others are actually known to be constructors in Python, and the reason is quite clear. The name itself suggests that these would be used to construct something. So these special methods having two underscores are known as constructors. Not all methods, those who actually have double underscore, are a constructor, but you can say that a lot of methods, those who actually have double underscores, former and trailing the name, are actually constructors. So what is the use of this self parameter now? So the purpose of this self parameter is to actually tell this function that it is referring to the current object, that is this object. In case when I'm referring to this object, and it will actually refer to the cat2 when I will be referring to this cat2. So this self parameter helps the machine to know which object I am currently talking of and which object it need to work on. So this is the main purpose of self parameter. And now I want to initialize the color and the age of every cat. So you can simply see that the syntax is quite similar to functions, and I should say exactly similar to function. And the difference is only that a method is that function which is defined inside a class, not independently. So to tell a computer that this color which I will be assigning some value to this color. So this color is actually belonging to only this object at a particular time. We use self. So so the syntax is self dot color is equal to color. Now don't get confused with these two colors. You might be thinking that we are assigning the value of this color itself to the color. No, this is not so. This is actually the parameter. You can name it anything. You can name it like appearance. You can name it appearance. But the only difference that will arise is when you are calling the property of this cat class object. That is, till now, if I want to print the legs of a cat, I simply use the same variable. That is, I simply use legs and I simply could print the legs. But when I define a, a variable after this self, it is actually set to the parameter of a particular of that particular object. Now, what do I mean by this is this self will make sure that this color will have a different value for each and every object that you will create using this class cat and initialize using this constructor in it. This was the simple meaning of using this variable after self dot. So why I renamed it appearance is just to avoid confusion. If I named it color instead of appearance, I would be able to call it using the the identifier appearance, and if I use the identifier name as color, then I would be able to access the property by using the color keyword instead of appearance. This is the only basic difference. Now, if I want to give the object an age, I will simply use self.age is equal to age. So this is a very, very simple blueprint of how a cat looks like. Now let me just remove all these so that we can write the code again for better understanding. If you are actually not getting how this self works and why do we need it and why this init is needed, so I would say that it will probably take time as every programmer will struggle with object oriented programming, and your case is not different. So you actually need to give time, try to read different sources and see different examples, look at different cases and try to code yourself so that you can better understand. Castle's analogy that I gave you will always be with you. So let us create an object, and this time I will create an object my cat using the class cat, and this time I will give it a color that is white color, and the age is 2 years. So if I'm going to print the age of my cat, now let me just add one more parameter, the initializer, that is name. So self dot name of my cat, when I call this using my cat dot name, it should return me the name that I will pass to this init function. So I will simply be assigning a name to my cat, and my cat's name is Lily. So when I try to print my cat dot name, you will see that Lily will be printed on the terminal. So what if I created another object using wildcat variable and make it an instance of this class? And now what if I try to print how many legs the wildcat actually has? So you might be expecting an error. As you can see, we have already got an error. So the reason is because we actually did not initialize the cat. We had to give the missing arguments, and here are the. So because I don't know the name, I will say anonymous, and the color, I know that it is black cat, and the age I don't know. So I will give it a value null. So I don't know the age, so I have given it null. And the cat, I don't know the name because there is no name, so it is anonymous. And the color, as far as I have seen, is the black color, so I will give it a black color. Now, if I try to print the legs of the wild cat and the legs of my cat, you will see that both of the answers are same. That is, both of the cats have the same legs. But what if I try to print the name of each cat? You see, you will see that my cat has a name, Lily, and the wild cat is actually anonymous. No one knows what is the name of that wild cat. So how did this Python interpreter differ the wild cat from my cat when I have already created them from the same class cat, and the code inside the class is same? So the reason is quite simple, because of this self parameter only. Now you might be wondering that is it actually compulsory to name this first parameter as self? So the answer is no. You can actually give it any name, like you can give it cat, or you can give it like this cat, because at a particular point of time it will refer to only that cat which we are assigning the value. So we can even use this cat instead of self. But self is actually used as a convention by the programmers to make things simple and clear, because self simply says that it refers to the object itself. And so we just use self keyword almost every time we are writing a class, but it is not compulsory to use the keyword, not to use the word self. We can actually use any other keyword, but we just simply have to remember that every time we are assigning a attribute to that particular object, we use that same word that we have is assigned instead of the word self, and the program will not give us any error in that case. Now let me just print the color of that cat. That is my cat. I want to print the color of my cat. So what do you think? Will I get an error for this line, or will I get a answer for this print statement? So the answer is I will get an error, and you can see that it says that cat object has actually no attribute, and this was what I was saying. Because I have named this attribute appearance instead of color, it is giving me an error. If I try to use appearance, you will see that the color is white now. And I have now discussed how this parameter, that is self parameter, or any parameter or any name that you want to give to the object to refer, works, and how you can name a property after the self parameter or the given parameter that you are using, and assign some value or assign the parameter's value to the property of that cat. Now, if I change this property to color, you will see that I can access the cat's color using the color property or color attribute. So you will see white again. Now, I hope it would have been clear to you that how we use the init constructor, or what is constructor, what is a class, what is an object, what is the technical definition, and what is the object instance of class, what is instantiation, what do I mean by instance, and the preference of the class attribute is lower than the preference of object attribute, and you can set a value for a particular object by changing the value of that defined attribute, and it will be simply changed. So now we actually have covered a handsome part from the topic oops, and now we will be heading towards the next point that I would want us to discuss, and that is defining methods in a class. Now, what do I mean by methods in a class? So I hope from the castle analogy you would surely remember that you, the winner, gave a speech on what the functions of a class are. Like you said, it can protect us from war. Like you have said, it can protect us in seasons. It can actually be our life savior in war-like situation, and it can be a safer place to live and grow. So these were nothing but the functions a castle could serve. In the same way, a cat can actually do many functions, like it can walk, it can roll over, it can speak, and many other activities like it can play and so on. So how do we tell the computer that the cat is now playing? So to do it, we simply define a method, that is play method, and in this play method we will be using the same this cat keyword or this cat parameter, so that we can tell the computer that only this cat which you are referring to the current instance is playing, not all the cats are playing. So to do this, we will simply use this parameter, this cat, and then actually we don't have anything else to take as a parameter to give it to this function, or particularly this method. So we will simply be printing in this play method that the cat is playing, and when I'm going to call this method, like my cat dot play, you will see that the terminal will print that the cat is playing. You can see that the cat is playing, and so you can see that the terminal successfully prints that the cat is playing, but it actually is returning a none because we actually have called this method cat.play, but this play method actually returns nothing. So instead of printing, let me just return the string this that the cat is playing, and now you can see that when I'm going to run this program, you will see only the cat is playing, not the nun. So you can see that when I run this method cat.play, it simply tells the computer that the cat is now performing an action. That is, it now needs to run a method that is cat.play so that the computer can know that this cat is performing a verb or it is simply doing something. So that is why we actually need to define these methods in a class. What if now I want the computer to forget about the cat that I was talking about and remember it only up to the time while we are actually talking about it and forget about it when we are not talking about it. So you can simply use another method, and this is del method. And now if I want the computer to actually forget about this my cat, I will simply use a destructor. Now constructors are used to construct the object and destructors are used to destroy the object, and you can simply understand it for now that destructors actually destroy the object. If you want to go into details, you can further read the documentation what actually destructors do. Now when I will call this function, I want the terminal to print successfully deleted. Now if I want to call this del parameter for my cat, that is, I want to delete my cat and I don't want the computer to know that something like my cat exists. I will simply use this, and do you think what the output is going to be? It says that the name my cat is not defined. Yes, you can see that when I deleted the object my cat using this destructor, it simply says that my cat name is not defined. Was the output the same when I had not used this statement? So the answer is no. You can see that it says Lily is rolling over. But why is it saying successfully deleted when it has actually not? So the reason is because this destructor is automatically called once you don't call it. That is, once the execution of entire code between this destructor and constructor happen, this will automatically be executed by Python. Now you might be wondering that this was something like magic, but let me tell you, there is nothing like magic. These constructors and destructors are some special methods, and these special methods are actually automatically run by Python when you actually create a class like this. And the code inside these methods is also automatically run. So every time like this rollover method and this play method, you actually don't need to call this del and this constructor that is init method, as these methods will automatically be implemented by the Python interpreter. And this was the simple reason why you were actually seeing this output successfully deleted, because Python interpreter actually has deleted the object because of this del destructor. Now we have covered destructor also. We actually should switch to a homework example for you that is similar to the class cat that we have created today you need to create the class dog and provide it with a name, age, color, and breed. Inside the init initializer and all the dogs that you create using the class should have four legs and a tail and two eyes. So this is a homework problem for you so that you can try creating a dog class similar to the cat class and practice what I have taught you today. One more thing that I would want to add up is create a dog object which is differently abled. That is, it has three legs instead of four legs. So you should practice doing by solving this question. And now let us move ahead. But one more thing I would like to discuss is you would actually hear something like getters and setters in Python. And let me tell you that getters and setters are no different thing other than a particular method that is used to set a name. For example, if I create a class human and inside that class I simply create a self and then I create a name and I assign it a name. Thereafter, I want to set age. So I can simply do this by using this, then the self parameter, then the age parameter, and then self dot age is equal to age. Now, when you actually use a different function other than the initializer function to set a different attribute, maybe predefined. So in that case, we actually call that function a getter function because it is actually getting a value from the user. And if we actually set a value, that is, suppose the age entered by user is something like so self.year contains the age and I want to use this self parameter only, and now another self dot age will actually contain the age of this, that is it will contain self dot year. Now this is a getter method because it is getting something from the user, and this is a setter method because it is setting the age, this age, or let me just name it something like, now if I want to set attribute which actually contains this value, so I can simply do that by using this setter method. And the difference between this getter method and the setter method is that this will get a value from the user and this will set that user taken value to a parameter. And you can simply run this code and check if it works or not. You will simply have to do it like human one as human object from the class human, and then you can give it a name that is Ram. And when I call this human one dot age, I will give it age like 15. And when I'm going to print the value of, let me just change this, that is set age, and let it be get age. And when I want to print the value of human one dot set age, what do you expect to be there? So let's run this and check if this code works. Let me just clear the terminal, comment this code out. Now let us check. It says human as not review page. Oh, it should be get age. Now when I run this program, you will see that it returns none because it is not made to actually return something. So let me just cut it and paste it over here and just print human one dot. Now when I'm going to run this piece of code, you will see the output to be 15. That is the age that we has taken input from the user. So we got the age as input from the user, and we use that age to set it to this parameter using this setter method. So this is the difference between getter method and the setter method in Python. So getters and setters are usually just the name given to this function itself, which are defined inside a class, but those functions actually serve a purpose, and the purpose is clearly visible. And a topic that is decorators is actually left to be discussed, but I am thinking to actually avoid the discussion regarding decorators because it is actually a quite difficult topic to digest for absolute beginner, and there may be many questions in your brain that are actually not answered up to this point of time, and the reason is because you will actually find the answer to those questions either by yourself by doing some research, or you will actually get them cleared over time as you will be coding out many problems by yourself. And as I've already discussed, that OOPS is actually a quite difficult topic for an absolute beginner to grasp, and this is the main reason why I'm not discussing what are decorators in Python. And decorators come under dunder methods, and I will not actually be discussing dunder methods too. So this was all about object-oriented programming system that I would want a beginner to actually know. And we have covered a handsome amount on the topic OOPS. And if you want to learn more about OOPS, then sky is the limit. You can actually learn many and many new things in OOP every day because OOP is a very big, very vast topic. So, what is inheritance? Will be discussed in the next lecture. And till then, keep revising what I have taught to you up to now. And if you actually did not get much from today's lecture, don't worry. Still try to read some documentation and and try to refer some resources. You will probably understand something.